Welcome back everybody to Daily Math Concepts. Today we're looking on some more statistics questions. As you can see here, comes at number 7 on the Add Math paper. All right, so here we go. All right, let's see what's going on here. All right, this question reads, let D be the difference between, so it says let D be the difference between the scores of the faces landing upward. So we're talking about two fair die being thrown. The table below gives the probability of each possible value D. All right, so we're seeing, so D represents the difference between the faces. All right, so that means two dice are thrown, should say, and we're subtracting the values, and then we're saying in what case will we get a 0, a 1, a 2 when we subtract, and so on. Definitely, to answer a question like this, we need to have an idea of our sample space. The sample space is very crucial, because if I'm going to represent the probability any at all, I definitely need to know my sample space. All right, my desired outcome would be over what number, and in order to do that, we're going to have to take the time to find out what's the case, how many possibilities for there to be a 0, for there to be a 1, and so on. So I'm going to set up like a little case here where we're saying, let's say we have dice 1 and we have dice 2. All right, and we're talking about a difference when D is equal to 0. For D to equal to 0, all right, for D to equal to 0, we would have to throw and get the same number. For example, dice 1 will get a 1, dice 2 will get a 1, we get a 2 and a 2, a 3 and a 3, a 4 and a 4, 4 and a 4, and a 5 and a 5. So when you get all those double numbers, 6 and 6. So if you should subtract these numbers, definitely you can see that you'll end up with a 0. What are the total possible things here? 1, 2, 3, 4, 5. We have 6. So this sample space is out of 6. So we have 6 chances to get a 0 whenever those dice are thrown. So let's see. Difference of 1. Talking about dice 1, dice 2, the difference is 1. We have 1 and 1 and 2 and 1. Then we could have 2 and a 3. We could have a 3 and a 4. We could have a 4 and a 5. And then we have a 5 and a 6. And then this is going to double. Like, you could flip this round, meaning a 2 and a 1 and a 2 becomes a 2 and a 1. A 2 and a 3 becomes a 3 and a 2. Because the numbers from dice 1 could be on dice 2 and vice versa. So this is 5 times 2, and it gives us 10 possible outcomes, right? So let's do, I'd have to get a 3 here and a 1 here, a 4 here and a 2 here, a 5 there and a 3 there, a 6 there and a 4 there, and then this repeats. So I'm talking about 4 outcomes, and it's going to double up, so I could get 8. From getting a difference of 2, we could get it in 8 ways, because you could double those. Let's go again. What about getting a 3? And you'll see what's going on, a difference of 3, dice 1, dice 2. All right, so a difference of 3, you could have, say, a 4 and 1 dice and a 1, a 5 and a 2. You could have a 6 and a 3. You won't, so a 6 and a 3. We're talking about getting a difference of 3, and then this could double because you could switch it around. So that's 3 times 2. And I'm getting a 6 right there. Dice 2, difference of 4. If you have a difference of 4, definitely this is a 5 and a 1. You could have a 6 and a 2, and you're going to spin this around. All right, so you could have a 1 and a 5 and a 2 and a 6. So 2 times 2, we're getting 4. A difference of 5. Dice 1, dice 2. We could have a 1 and a 6. Or a 6 and a 1. So that's just 2 cases. Let's go for our total. So our total number, 10 plus a 6, plus a 6, plus a 8, plus a 4, plus a 2. All right, good. So if we should add up these, this will give us our sample spacing that we want to work with. So we're talking about 16, 12 is 22, 32. So this is a total of 36. So that's my sample spacing here. So it took us a little time just to put these together because we have to work out these in order to respond to the question right. So my sample spacing is 36. So you could see now to get a difference of 1, remember we worked it out to be 10. So we had 10 possible outcomes. So we're talking about 10 out of 36. If you want to cancel down this by using 2 into this goes 5 and 2 into this goes 18. So A is 5 out of 18. B, the difference of 3. The difference of 3 is 6. All right, so for a difference of 3, we're talking about having 6 out of 36. And if we divide this by 6, we'll end up with B is equal to 1, 6, right? And to have a C, a difference of 5, I think it was 2. All right, that's it. We have 2 possible outcomes. So we're talking about 2 out of 36, which means it's 1 out of 18. So there it is. So C is 1 out of 18. So that's the possibilities that will have the probabilities to have those differences right there. Let's go to the next question. So the next question now is, it says that we have an aptitude test, right? The next question says that there is an aptitude test. The aptitude score obtained by 51 applicants for a supervisory job are summarized in the following stem and leaf diagram. So we have 51. So we know that it's 51 applicants, all right? We'll get the key here for the stem and leaf. It's telling us that, hey, if you see a 5/1, it means 51. All right, let's see the questions that they want to ask from this. All right, the questions that they want to ask from this. Let's go for that. All right, so the question that they're asking is number 1, find the median and quartiles. Oh, find the median and quartiles. So we're going to do some working out here. They want us to find the median as well as they want us to find the quartiles, right? All right, definitely we're going to put that together. Let's go. The median is a middle term, which is Q2. So all we have to do, if this is 51, right, then the middle number would have 25 applicants on the right, 25 on the left, and then this is our middle. So we're looking for the 26th term. So I have to count 26. Just count like let me use my marker. All right, so we're counting. So we're talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, which is 71. So this is the 71. All right, remember though, the reason why I could count it like this is because these are already organized. This is 31, 35, 39, 42, 44. So it's in order already, because whenever you're going to pick the median, it has to be in order. All right, so remember now that is, we just picked up our Q2, which is 71. All right, so Q2 is 71. We just picked that up right there. All right, let's go to the next question. All right, so the next question says, construct a box on Wishka plot to illustrate. Oh, we're not there yet. We need to find all the quartiles. My bad. So let's go to the quartiles now. All right. So in going to the quartile, I have Q2, and I just need to find Q1. All right. Q1 would be half of the first half. So these numbers here, all of these here will be my first half, and everything from here, let me mark this off. Everything from here will be my last half. All right. That's the last half. All of these numbers are the last half because this is Q2, which is the median. So all I have to do is to pick the middle of this. Remember, it's 25. So I'm going to pick the 13th term. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And this is 56. So Q1 is 56. Even though it's a 6, remember 56. 5 and 1 and 6, 56. Q3 is going to be the half of this half. It's still going to be the 13th term. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is 79. So Q3 is 79. With this information, I have my quartiles, but I need I need interquartile range. So my interquartile range, because they did say all the quartiles, is going to be Q3 minus Q1. And then that's going to be 79 minus 56. And then that's going to land us a 23. All right. So 23. So 23 is my interquartile. And then there is what we call semi-interquartile. So the semi-interquartile range is going to equal to Q3 minus Q2. My bad, Q3 minus Q1 all over 2. So based on what we have, it be 79 minus 56 and divide this by 2. So that is going to give me 23 divided by 2. This is 11.5. So that's my semi-interquartile range, 11.5. So with that said, we would have found all the quartiles that they had asked for. There are all the quartiles. Now, when you have the quartiles, then the box and whisker will be something so easy to do. So it says construct a box and whisker plot to illustrate the data given. All right. And then drop a comment on those distributions quickly. All right. So definitely, we're coming from 31 all the way up to 96, right? So I'm just going to quickly drop a line. I'm just going to drop a quick line here. I'm just going to drop a quick number line here. So I'm going to put on it. I'm going to read from 30. So coming from 30, 40, 50, 60, 70, 80, 90. And I just say 100 because I have scores from 31 all the way up to 96. All right. So what we're going to do is to drop our median first, which is at 71. So 71 will be, so I'm going to just raise it a little above the number line there. So 71 is going to be just a little over 70. This is about 75. So I'm going to put 71 about here. All right. So I have that. And then now, after that, I'm going to go to my upper quartile, which is 79. And 79 is going to be right next to the 80 right there. And then 56 is going to be a little bit over the half mark there. So I'm going to have my box. So when I put my Q1 and my Q2, so this is Q2, this is Q3, and this is Q1. I set up that, and from that, I'm going to put on my range now. So 31 will be somewhere down here, and there 96 is a little over 95 there. So we should just a little bit over that, and then that. So this is what we refer to as our box and whisker plot, where we're able to use the quartiles and construct a nice box with a whisker here. So this is that. And if you want to comment though, you could see something here that the scores, look at this. I'm seeing where if I look at the distance between, if you look at the distance between the Q1 to Q2, which is the median, and then you could see that it is negatively skewed. All right, we could see that this is negatively skewed because we have a lot more scores from Q1 to the median than from the median to Q3. So you could see that the gap between those two, you understand? So we could look at that. All right, so it's sort of negatively skewed. All right, thank you for watching. If you think you like this, please like, share, and subscribe to Daily Maths Concepts and look out for more questions. Bye-bye.